Hey, welcome to Virtual Azure Community Day. This is your virtual live Azure event, community event with speakers. We're doing multiple sessions, so around this time, hopefully France has started as well. So if vous talkez français, then you can go. That's not French. No, but if you talk French, then there's a French spoken track now as well, and we're broadcasting live from Denmark. But you're currently watching the track live from the Netherlands in Utrecht in our lovely, lovely studio. And I have two guests here. Somebody from Microsoft and somebody from Solo walked into a bar. I always wanted to say that. It's funny. So last session was more about like making it more obfuscating Kate's even more, adding another abstraction layer with container apps. But you're going to dive a little bit deeper. What if you're using Kubernetes and you want to, well, add extra functionality, you want to expand your application, then you at some point will need sidecars.
You do need a service mesh. That's the whole idea, and that's one of the reasons why I joined Solo.io recently, is because, as I say, I'm on a mission to install a service mesh into every cluster out there. I believe, I think it's very well established that a service mesh is a very convenient add-on for cloud native applications, right? So you kind of you may think you don't need it, or you think it's an overhead, but the advantages it brings and the small overhead, the small price you pay, it justifies the investment in terms of cost and computing power that you need. And today we're going to talk about a way to even reduce this footprint, this cost associated with the service mesh.
So it's more basically talking about leveraging the power of a service mesh, but then in a better way.
Yeah, with less friction and less waste, which is what everybody should try for, right?
Yeah, a lot of people. I don't know about you, but a lot of people I talk to when we talk about this is like, yeah, but it's so much work. It's a hassle where we're already happy that we came this far, and now we just need an add another layer of complexity, actual adding extra knowledge. So what you're gonna talk about is gonna remove that friction.
Reduce
The
yes.
friction. Reduce.
Yeah. Everything is worth it costs a price, right? So everything that we do has an impact on complexity and cost. But there's some cost benefit consideration, and I'll make a case that it's probably very worthwhile to invest some time and some CPU cycles into a service mesh.
Yeah. Okay. And also, if you already have a cluster running, Istio service mesh installation is just a couple of commands. Like it's very simple. So the notion of that it is really hard to install is, yeah, it's not really the case.
Is it maybe the fear of the unknown?
I think so. Yeah, I definitely think so. Yeah.
So you are gonna show us also a demo. You told me backstage. You told me it was quite experimental.
Yeah. So Istio service mesh, the standard release is very stable and a very good way to install, to have a service mesh running on your Kubernetes cluster. However, the one we are talking about today is the service mesh in Ambient, and that one is way less uses way less resources. It's a sidecar less model, but that is currently an experimental. It's currently an experimental version. So yeah, we just want to show that it works and that you can use it. However, it is for production use. We will recommend to wait a couple of releases until it's a stable version.
Where's the adventure in that?
Yeah.
No, all jokes aside, I'm really looking forward to that and looking forward to that demo because nothing is cooler than experimental stuff. Yeah. Looking forward to your talk. Good luck.
Okay.
Thank you.
Thank you. Should I start?
Yeah. So again, thank you for watching Virtual Azure Community Day. If you want to share anything on the socials, where are you in the world? Where are you watching? Are you enjoying this show? Do you have opinions on service mesh, experimental stuff? Want to cheer on for the demo? do so using hashtag VACD or leveraging the chat on our website, azureday.community. Take it away, Alessandro.
Thank you. Thank you very much. So we've been invited, thank you very much, because it's our first time and at Virtual Azure Community Day, and I would like to thank everybody for trusting us. Today we're going to talk about Service Mesh and a special variant of one of the most popular Service Mesh, which is Istio. So please bear with me. What we're going to show as a disclaimer, of course, these are not exactly production-ready stuff. So it's going to take some time to mature. That as everything, once even Kubernetes was a beta, right? So no fear there, and just bear with me and come into the adventure. My name is Alessandro. I run the Dutch Kubernetes meetup. So I've been doing Kubernetes for some time, and I just joined, a couple of months ago, a company called solo.io. You can ask me anything about it later. I need to switch screen? Yeah. So clearly. Oh, yeah. Okay. Yeah. No. Wait, let me.
Can you do it?
All right, sorry for the misunderstanding.
Yeah.
So yes, I'm Alessandro, and I'm joined by Mark. He's also he works at Microsoft. Of course, we started this to talk about these things together a few months ago at the meetup, and somehow we really like these ideas, and we like to talk about it. So if you don't know Service Mesh is a very popular addition to Kubernetes, of course, but it can also be extended to virtual machines and other non-cloud native workloads. It's an idea been around for quite some time. Among the Service Mesh, of course, there's not only one, there's many on the market, but there's one that kind of emerges like the leading Service Mesh in the community and in the markets, in the industry, which is Istio. Istio was born out of Google project, of course, like many other things, like Kubernetes itself, and of course donated to the Cloud Native Computing Foundation, recently donated to the Cloud Native Computing Foundation. So we are talking about a project that has open governance, is of course open source, is based itself on open source, open governance, and another very popular graduated project in CNCF, which is Envoy. Envoy is one of the most popular proxies out there, one of the most efficient, one of the most adopted. So the foundation is very solid, it's open source, and Istio itself is extremely solid, extremely well received and adopted by many customers in production. So you can look it up. It's now a CNCF project. So recently, of course, like in around September timeframe, this new mode of deploying Istio was born, called Ambient Mesh, and that's what we're gonna talk about today. So this is not, unfortunately, we don't have that much time to talk in depth about Istio, what is a Service Mesh. Of course, we'll be happy to have other sessions about it. But in short, a Service Mesh is an add-on, something that you add to your workload, so you can leverage what Service Mesh can bring to the table. So the most classic model for deployment of a Service Mesh is the sidecar model. If you read the Brendan Barr's book called Design of Distributed System, you may know, or if you already work with Kubernetes, you may know there's this pattern called sidecar. So this is the classic Service meshes out there leverage the sidecar model to inject a proxy into every workload. Namely, in Kubernetes, of course, it's every pod gets its own sidecars, because a pod is a construct that can be made of multiple containers. And so Istio leveraged this capability of Kubernetes of having admission controller and a mutating webhook to actually modify your workload definitions, your pods definitions, by adding an extra container to it. It's all nice and well. What can this container do? This container really runs Envoy proxy, so it's just a very low footprint proxy that sits next to your workload, to your application, and hijacks the traffic in and out of your pod. That's done by classically through reprogramming the IP tables in the pod namespace, right? So that's the whole point of this talk, is to show that there are other ways to do it. So once you have every application injected with the proxy, now you are able to do interesting things, right? So all these proxies, of course, are managed and programmed by a control plane. So in Istio, this used to be a plethora of multiple services. So Istio control plane used to be distributed service system, but now it's been consolidated into one binary, also written in Go, like many other things in Kubernetes. So the Istio D is the process running also in your cluster that manages the configuration of the proxies that live next to your application. So what this all brings to you, right? So it brings to you observability. So you can measure, you can collect metrics out of the proxies for every single pod, every single application, collect them and show it and use them to reason and to understand more about your workloads. So Envoy proxy is a very granular collection of metrics, and of course, like get the numbers of requests, the numbers of rejection, all the HTTP codes that comes out of your application, and all the requests. That's one big reason to adopt service mesh, is to have a better view inside your application. Another things you can do with having Envoy proxies, having sidecars into every pod, is to enforce security. So security policies. Those can be, for example, policies that dictate which service can talk to which service over which port and over which path. If it's a HTTP request, you can secure and lock your workloads more granularly than just network policies. So these are something that people tend to confuse together. So of course, like if you don't know network policies, these are also extension to Kubernetes that controls the layer 4. We call it the layer 4 because it's all about the TCP layer. So which IPs can talk to which IP. So it's really at the TCP IP layer. So network policies are very common, probably enabling every cluster you use. You can control which service can talk to each service, but based on their IP properties. Service mesh allows you to build on top of that and go up to the layer 7, where you can actually reason about application networking security, as in you can tell that which application and which service account that application relies upon is able to talk to which other service and over which port and which protocol and which path, for example, for HTTP requests. So observability, security, and of course, like managing of the application is another big reason to adopt service mesh. So this is the classic reason why service mesh is preferable, right? So as we discussed before, surely there is a price to pay. There's more complexity, and we'll talk about how to scale down this complexity. But it's something that I personally like to have into every cluster I manage. I like to know what's going on. I like to know the error rates, and I like to know per workload. I like to be certain that communication between my pods are secure. So one thing that I didn't mention, of course, being able to have a proxy for every pod let you establish mutual TLS between those workloads. So this is another big reason why adopting a service mesh is preferable. It's can keep your sleeping at night. It can give you peace of mind. Is that the proxies can establish a two-way secure communication between each other. So no more unencrypted communication between the proxies, but the control plane can manage and inject these certificates in the proxies and make sure that these proxies every time they talk to each other, the communication is encrypted by this certificate. This is why it's not great, right? So sidecars are great until they're not, right? So they've been serving us for so long time, and for most use cases they are pretty okay, pretty lightweight, right? So and then they don't add too much complexity. But of course, when you scale up and you start to have hundreds and thousands of workloads per cluster, then you can feel that this becomes a problem. So this is actually what happens, and this is taken from a great blog from Jimmy Song, a very famous picture. So this is actually what happens when this sidecar proxy is injected in your pod and starts to hijack, starts to intercept every connection in and out of your application container. So you can see that there is a bunch of IP tables that needs to be programmed and changed. So this is actually another container that is injected in your pod, which is the init container. So that prepares the IP tables. IP tables are extremely popular mechanism to, well, it used to be, well, the original function was a firewall, right? So intercepting and managing connections to a Linux box, to a Linux machine. Of course, now they expanded also into Windows, and they can do many more things, like make some smart decisions what to do with specific packets. And in this case, the Istio proxy, the sidecar proxy, use them to intercept the traffic and then redirects all the traffic to itself. And only if after evaluation of this, talking about the application networking policies, then only then forward the traffic to the application. So this is great. It works, just maybe too difficult to understand. I mean, also I struggle understanding this complex IP tables rules. So that's why from the pain of managing all these sidecars, also the actual impact on your wallet. Because imagine, so all of a sudden you enable service mesh in your cluster. You don't need to enable it all of nothing, right? So you can start to onboard your application in service mesh slowly or at your own pace. So because the service mesh usually is enabled per namespace. In this case, when a namespace is tagged with a particular, I think we also, that's what we do in the demo. When we tag a namespace with a specific annotation, the namespace starts to become, the workloads in that namespace will have the injection enabled. So, but even then, you can imagine now you have a workload made of, for example, 100 pods, which means 100 containers, and then you enable service mesh, you jump up to 200 containers because every single one needs a sidecar. So all of a sudden you double the amount of containers, double the amount of complexity. Those containers, of course, the sidecar, the Envoy proxy, they do consume some resources, so you end up with like oversizing your clusters because you just want to have these nice features of service mesh. Can something be done about it? Let's see. Is the whole point of Istio is to reduce cost simplify your operation, and of course, like, also improving performance. And we'll dive deep into this in a moment. So, what is service mesh? What is ambient mesh? On the left, you see the classic model with a sidecar per pod. Now imagine you can combine these sidecars into one proxy and run it per node. That's all you need, right? So that's all what is necessary. So all these pods living on the same node, they can actually have their communication, their traffic intercepted by one proxy, and that proxy will serve multiple applications. So this is something that kind of strike the minds of the people behind ambient mesh, behind this new mode of operation, was to reduce the complexity by aggregating the proxies into one. So instead of running multiple proxies, running one per node that can serve multiple workloads. Only, of course, the workloads tagged and that needs the proxy. So also, as I explained before, the proxies per node, they serve both the function of layer 4 proxies and layer 7 proxies, right? So they do perform two functions, right? So forwarding packets, of course, at the TCP/IP level, but also making decision about the application layer and what application can do and what cannot. So imagine if we can split these two roles into the node proxy, what we call the proxy, the data plane, and a new proxy, we call it the waypoint proxy, dedicated to perform layer 7 decision, layer 7, enforcing layer 7 policies. So this is also a way to reduce complexity, because you can split the roles and the responsibilities into different proxies, all based on Envoy, of course, but just different, very different in their roles. So this is how it works, right? So we take all these proxies, so we don't inject anything into the pods. Makes it much easier. First of all, you have to consider that injecting the act of manipulating a pod definition and adding a container will force that pod to be restarted, because there is no hot injection of containers in a pod, at least not possible for now. So those pods needs to be restarted, which will incur some downtime, make some people uncomfortable to restart the pod. So it's something that we look forward not to have to do, right? So instead, you deploy a ambient mesh, so Istio in ambient mode. Then all of a sudden, there's a daemon set that deploys a layer 4 proxy based on Istio, on Envoy, on every node. And then that proxy will get the traffic of the tagged workload into itself, and will communicate with the other layer 4 proxies on every node, making a mesh of communication. Now, if a workload is also a layer 7 associated with it, an application policy associated with it, then, and only in that case, that traffic will go through the L7 proxy. We call it the waypoint proxy. So if you don't need layer 7 forwarding, then you're not going to use it. You just a pure communication encapsulation of your traffic between the layer 4 proxy between the nodes. So that's why you save resources, because you only use it when you need it, and you save complexity because you drastically reduce the number of containers or processes running on your nodes. So not only you can, of course, still obtain mutual TLS between the applications. So sure, it's not done between sidecar proxies, but it's done at the Z tunnel, which we call the layer 4 proxy sitting on every node. So those Z tunnel, which are just pods, right? So they are just daemon sets pods running on every node. They will establish mutual TLS between them. All the certificates are still managed by the Istio control plane. So these are all, you can normally, I mean, at least for development in our demo, of course, we rely on the internal certificate authority, but you can choose to have an external certificate authority, use cert manager, or rely on Active Directory or HashiCorp Vault to create those certificates authority and those certificates that will be injected in your zTunnel or your corporate CA PKI infrastructure. So these tunnels between the zTunnel will convey the communication, the traffic between the workloads running on each node. While the layer 7 is performed by a separate proxy that again sits on the nodes and needs it, sits on the node that actually run the workload that needs to be secured via layer 7 processing. And while when you don't need to, nothing's gonna pass through that waypoint proxy that we call. So this is how we visualize it, of course. So this Istio-D is still configuring the Z tunnels and configuring the certificates, making sure that things are running smoothly, and there is of course, like the Z tunnel is aware of which workloads they need to be forwarded through the proxies, and that's how it works. So, and we'll talk about what is this tunnel, how does it look like. If in the case that some of your workloads are actually in need of a policy, so application networking policies, or with layer 7 policy, then and only in that case, the Z tunnel leaving into each node will, instead of directly sending the traffic to the Z tunnel on the other side, they will use the waypoint proxy to perform those policies, to apply those policies. So this all done very transparently. The waypoint proxy is actually makes its decision based on the SPIFFE identity of your workload. What is the SPIFFE identity? So every workload in Kubernetes, of course, has a service account associated with it. That service account represents the workload identity. So what that workload can perform, and the identity of their workload is really their service account. So based on that, based on the service account of your workloads, the waypoint proxy will make a decision. So you can limit what a service account, and conversely the workload associated with it, can do by just creating these rules and this waypoint proxy. Internally is another CNCF project called SPIFFE. It's topic for another talk, of course, but it's all internally representation of those identities. So this is how internally it works. So of course, like, it would be not very efficient, or not a lot of improvement if every Z tunnel would need to open a new connection for every connection that those workloads needs to establish. So that's why there's this. It leverages this mechanism, which is really part of the HTTP protocol. It's the HTTP base overlay network encapsulation protocol based on HTTP connect. It's a verb in the HTTP protocol. So the tunnels establish one connection, and they reuse the connection to send traffic over. That connection is of course like secure, but kind of the traffic is kind of multiplex inside the connection. So that means that there is no need to reopen new connections. There's no need to waste cycles of computation or network connections by reopening for every new connection that your workloads want to establish. So there's one connection between between all the tunnels, and your communication goes through it. You don't need to. You don't see all of this when you're running. Of course, it is all internal working of the Z tunnels. But it's very interesting to understand it. It's very at least I'm an old school network guy, so I like to understand how my traffic goes around in my clusters. So if you want to know more, and this is where of course my affiliation comes in, because we like more people to understand these ideas, right? So the more people know this, the better, because it's the future. We wanted to talk about what is gonna happen. 2023 is probably gonna be the year you will see a lot of this concept, a lot of this new ways of thinking about service mesh maturing and becoming more and more popular. We have an academy, so there's free trainings out there. We have an Ambient Mesh workshop where you can actually get your hands dirty and try it out, how ambient works in real life, or at least in some test environment that we spin up for you whenever you need. So with that, I will leave the floor to my team friend, Mark.
Yeah.
So thank you.
Hi everybody. So I will do the demo for today, and yeah, what we want to show you today is actually how Istio works in ambient mode. So let's start. A few pointers. The demo. Wait, let me quickly set it up. So the demo that we are going to do today, you can do yourself. I will show quickly where you can do that. We will leave links eventually. So the demo that we're going to do today can be found at codingkitties/Istio ambient service mesh tutorial. So yeah, if probably something goes wrong today with the demo, and then you can follow it in your own on your own pace, and then hopefully it will work. So that's a nice thing. So let's quickly set up everything for the demo. Ooh, most yes. Okay. So I've installed on my machine. This is an Ubuntu machine, and basically I have here a kind Kubernetes cluster running with Istio installed in ambient mode. So to give an idea of the Kubernetes cluster that we have running, we have here the Kubernetes cluster with all our pods. So basically, here's a demo application is running on this Kubernetes cluster, and this Kubernetes cluster consists out of 3 nodes. So here right away comes a very important concept. Because we are running Istio in ambient mode, we only have a mesh, an Istio service mesh per node and not per pod. So previously, you would have per pod, you would have for every pod a mesh running. So with all your network processors and such, all your add-ons. But now, because we have now we have Istio in ambient mode, only a single mesh is deployed per node. So as we can see, we have here 3 nodes, so we should have then approximately 3 Istio nodes running, meshes running. Sorry. So we can validate this by checking our resource of Istio. And as we yeah, so as we see here, we see that we have 3 nodes running. So 3 Istio nodes. So basically our meshes corresponding to our nodes of our cluster. So that is already a huge improvement compared to the previous version of Istio. And yeah, you can already suggest that this will increase performance of your Kubernetes cluster, will better resource handling, and just overall a better experience. Well, this demo we want to show that Istio in ambient mode is similar to Istio, Istio as we all used to it. So we can do, for example, we are now going to show we can do network processing with level 4 and level 7. And we can, for example, also do some common use cases such as installing an add-on in our service mesh. So let's first show that we can do some network layer 4 processing. So one very important part of that is, for example, mutual TOS. So to prove that that is running in Istio ambient mode, we can we can load up the certificate. Let me quickly get that for you. Keep in mind I'm doing this demo live, so it can fail. It is Istio ambient is in very experimental version, so it can fail, but we will try. Let me get the detail. So let's check the certificate that is running on the cTunnel. So here we already see. So as we suggested, like Istio ambient Istio service mesh in ambient mode has mutual TOS enabled by default. As we can see here, we can load up the certificate, and we are now sure that the service-to-service communication is done via mutual TOS. We can also do layer 7 processing, so that is also really cool. So let's look how we so layer 7 processing is done via a waypoint. And to show that the waypoint is running in Istio in ambient mode, we can do this. And here we see currently our waypoint running. So when we, for example, now call from one service to the other service, we do a request, we can know that it goes through a waypoint, and we can do the level 7 network processes, network policies. So that's really cool. And let's now do the last part of the demo. So for example, what a lot of people do with Istio Service Mesh is install add-ons. One very famous, very popular one that people a lot use is Kiali, the Kiali dashboard. Basically, Kiali dashboards allows you to track the routing of the requests through your cluster. So for example, if one service calls the other service and that service calls the other calls another service, then we can track which route the request will go. So that's really cool. It's more like an observability dashboard. Well, it's really easy to install, but I already installed the add-on for the demo purpose. But let me quickly show it. So as we see here, we see here that we have already the Kiali service installed. Installation of this add-on is the same way as you do it with normal Istio service mesh. And to get access to the dashboard of Kiali, we can quickly do. We can quickly go this. here we have our Kiali console that basically monitors our cluster. So this is Kiali dashboard running in Istio ambient mode, and then we have our cluster here. And let's select our namespace. So here we see our nodes running. Basically, our nodes and our pods running into it. And if we now, for example, do a request from one pod to another pod, we should see the request route. That, well, the request trace of that. We see. So here we went from, we used the sleep pod, and we called the product page pod. And if everything is correct, we should see. Oh, I think I have to. Yeah, I think it's not showing up, so that's a bummer. Okay, well, this is basically, as we pointed out, that yeah, Istio in ambient mode, Istio Service Mesh in ambient mode is quite experimental. It somehow does not show the request path, but it should be. So as we pointed out in the beginning, if you try to do this demo yourself on the GitHub page that we showed, hopefully it will work for you. Today not, but yeah, that's the thing doing with a live demo. So yeah, that was our presentation, and I hope everybody learned a lot from it.
Thank you so much. And there were plenty of warnings of this being so no hard feelings. It was really really cool, and yeah, it was so nice to see this. Well, hello,
Hello, back.
welcome back. Um, so people can get started using the GitHub page that you shared.
Yeah.
So from a scale of 1 to 10, how difficult is it to actually get started? It looked quite simple, but obviously you've prepared it quite well. So
Yeah. So shall I first answer? Standard Istio Service Mesh is really easy to install. Like for example, on the documentation pages, you can find everything. It's just a couple of simple commands, and you have Service Mesh running on your cluster. In ambient mode, it's just a bit more difficult because it's experimental. Things will change. They also warn a lot. They make a lot of warnings that, hey, this is experimental. This probably does not work. We have these systems that don't work. So yeah, I would not recommend to run any production cluster in Istio Service Mesh in ambient mode, but Istio, the standard release, is amazing.
but it sounds kind of like this is the right moment to start learning.
It's always the right moment to start learning.
Exactly. We can't stress that enough.
Definitely,
Yeah.
it's a good moment to start learning all things cloud native, and Service Mesh is we believe is going to be even more popular in this year.
Okay, I've turned on my microphone. Okay, so that was not disruptive at all. Thank you. Now I lost my thought there for a moment. I was going somewhere with this question.
Learning.
About learning, yes.
Okay.
Oh yeah. So now is obviously a good time to learn. which is of course always the case. So what knowledge would one need to gain before getting started to this point? Because like what a lot of people do is like walk into the candy store. Oh, it's
Yeah.
cloud native. There's so much shiny tools.
This reminds me of we were discussing with a colleague of mine, Marino. What we noticed that a lot of people enter DevOps, enter cloud native without really the good foundation of networking. I've been learning thing for a long time. So first thing I learned was like how a TCP packet is made of and what retransmission means and all the very basic networking foundation. And we feel like the new generation of DevOps don't have this basis. So
No.
I would suggest you go really slow and learn all the intricacies of the Linux networking stack, what the network namespace means. That, of course, it's probably things that you will not need in your daily job, but it gives you really like the feeling what is really going on under the hood. So you can install these things and you can install Istio, Ambient or not, and it works. But you get all these envoy proxies. You can actually go in and see what they do with the packets, right? What they do with the network connection. That's for me is like I'm all-time geek. I really love to have this this way to look inside what's going on. But yeah, in a normal day-to-day operation, you don't need to see. But it's good to it's reassuring to have this visibility into the kernel. We haven't talked about the BPF today. Of course, there's a whole new thing on.
You can spend an hour on that probably.
You can spend more than an hour. We also have courses and workshops about the BPF. It's becoming the de facto standard to mangle and to manage connections in Kubernetes, outside, in general, wherever our Linux kernel is involved, and by the way, also the Windows kernel, also implementing eBPF. So everywhere there is a connection, there is a network connection, you may soon enough find a eBPF program that can do something about the connection, like collecting metrics, doing security. So this is also, we haven't talked about it, but this is also part of the future of the service mesh and in general, like networking in Kubernetes.
Okay, so it's good to hear that where it's going, but it also reminds us all, hopefully, to go back to the basics and actually learn what is networking, learn what is networking under Linux or under Windows, and really understand more what is actually that technology.
Yeah.
Because we're all moving like to the right-click deploy thing.
Yeah.
It was mentioned a few times today. That's not the real world. Running an application does not only depend on your compute.
Yeah. And for me, like I'm quite new compared to Alessandro. So for me, if I would deploy my applications on the Kubernetes cluster, I would just deploy them and would not really think about, hey, how does the service-to-service communication, is that secure? Is there a TLS connection? Nothing like that. And basically, when I started with Istio Service Mesh, of course you read about it, and then you learn really quickly that just installing it already allows you to have pod-to-pod connection in a secure way. And it's just a simple command. It's just installation, and then you already have it out of the box. So for me, that was a really eye opener. Like, hey, there's not really that much of a hurdle to install this on your cluster, and it improves your structure so much. I think yeah. And then from that point on, you go like, oh hey, let's install some add-ons or do some level 7 network processing policies. Yeah, it's all pretty cool. So yeah, that's how I learn. But,
that's amazing to hear, because that is a realistic scenario, of course, and you need to start somewhere.
Yeah. So I think yeah, for me, as Alessandro was telling, like every Kubernetes cluster needs to have a service mesh. Me like working daily with Kubernetes cluster and making new ones on the fly. Like there's no need to not include a service mesh. Like it's really easy. So yeah, I think that's great.
Cool, but not the experimental one. Don't,
no.
don't,
as
don't.
we saw in the demo.
Don't do the bleeding edge stuff.
As we saw in the demo.
But
like,
learn. Start to learn it, because it's worth it. Okay, thank you so much for being here, for sharing this. And yeah, if you're watching this, do try out the workshop yourself. Take all the time you need and learn networking. and learn networking.
Thank you.
And learn networking. Okay, thank you so much, and yeah, hope to see you again.
Thank you for having
Yeah,
us.
thank you very
Bye,
much.
folks.
Yep.
We're gonna go for a short break before our next speaker is here already. We're gonna move some stuff.